Hey guys, we are now going to solve the problem of finding the median between two sorted arrays. Basically, merge the arrays A and B and find the median of the result. Here is a sketch of how we are going to tackle this problem. First, we define two pointers P and Q respectively for the arrays A and B. We are going to take the smaller array and set it to be A. So the length of B is gonna be either equal to or greater than that of A. So the pointers P and Q are defined in such a way that K, which is the position of the median, is the sum of P and Q. Basically what I'm saying is when you merge the array, there are P elements from A and Q elements from B which sit before the median and the rest of them sit after. P and Q are 1 indexed, not 0 indexed. So I and J are their 0 indexed counterparts. And coding wise, we are gonna be using I and J. You can basically estimate I using the two pointer method, where the two pointers serve as bounds of I. So the two pointers that we are talking about here are different from the two pointers mentioned here. So these are the bounds of I. So here's a concrete example. We have A of length 5 and B of length 7. The total is 12. We are going to make partitions. So the partition has to start somewhere. So we set I equals 2, which is roughly half of 5, so that the partition starts in the middle. And then we look for a condition. As we can see, 1 is less than or equal to 3 and 5 is less than or equal to 5, because A and B are sorted arrays. We also need to check that for the median to be on the partition boundary, this one, which is the left partition's extremity in A, it should be less than 5, which is the right partition's extremity in B. The same should be the case between 3 and 5. That's why the left 5 and the right 3. Because for the median to stay on the partition, all the elements to the left of the median should be less than or equal to the median. All the elements to the right of the median should be greater than or equal to the median. So if 5 should be less than the median and 3 should be greater than the median, then 5 should be less than 3, which is not the case here, which means this partition is wrong. Also, for this problem, these partitions can be moved in such a way that the total number of elements before the two partitions stay the same. So the total number of elements here are 6. So 2 in A and 4 in B. You add them to get 6. So no matter where you move the partitions, you will have 6 elements before the partitions. So after moving the partitions in such a way that the previous conditions are satisfied, you get this. So here you have 3 and 4 on the left. So these are less than or equal to the median. And 7 and 5 on the right. They should be greater than or equal to the median. Also check that 3 is less than 5 and 7 is greater than 4, or 4 is less than 7. Since that is being satisfied, it means the median should stay somewhere here. Either it is one of these 4 elements or it's between them, depending on the total number of elements in the combined array. So in this case, we have an even number of elements. 7 plus 5 is 12. 12 is even. So the median is going to be the mean of the center elements. So you need to find the center elements. So the left center element would be the maximum in the left partition. So the maximum element in the left partition is the bigger number between 3 and 4, which is the max of 3 and 4. Similarly, the right center element is gonna be the mean of 7 and 5. Sorry, not mean, the minimum of 7 and 5, because that's the first element in the right partition. So you got max of 3 and 4 plus min of 7 and 5 by 2, which is 4.5. So 4.5 is the median of the combined array of A and B. Alright, let's start with how to properly implement the solution. We'll first write down the pseudocode, then we'll translate it into a bunch of coding languages, Python, C++, and Rust. Rust as well, because why not? So, okay, let's begin. We got nums1 and nums2, which are our arrays. We set A to be the smaller array. We set B to be the larger array, and then n equals lengths. So m's the length of A and n's the length of B. Now first we need to deal with the case where A can be empty and B isn't. So if A is empty, so this would be a corner case. A is empty. The median is the median of B. Return median. Now, I don't think B can be empty because B is the larger array. So next, we set the 2 pointers like discussed before. Pointers low, comma high. Estimate I. So I is the index where the median might be in A, and J is the corresponding index in B. So low equals 0, high equals m. There are the two extremes. So what this means is, if I equals 0, then the median is to the left of A. If I equals m, it means the median is to the right of A. Remember, the elements of A can have indices from 0 to m minus 1. So if I is somewhere from m1 to m minus 1, it means the median is within A. So low keeps going to the right. Low keeps going to the right. And high to the left. We'll show later. As long as low doesn't cross high. So this is a while loop. It is implemented as a while loop. As long as low doesn't cross I, you basically define I and j here. I equals low plus high by 2. So this is typical of the 2 pointers method. You have the 2 bounds and then the estimated value of I is right in the center. And then j equals k minus I. Oh, I haven't defined k. K is basically the position of the median in the merged array. So k is basically something like m plus n by 2. It could be plus or minus 1. We'll face it when we get to the code. So now that k has been defined, we got I, we got j. Now we need to define the left and right elements for each array. So you have AL, AR, BL, BR, which are on the either side of the boundary. AL equals, so by default it's gonna be I minus 1, but that's only if I is greater than 0. If not, it's gonna be negative infinity. It's the same with AR, A of I. If I is less than M, else it's gonna be infinity. You do the same with BL. Change this to B, change this to J. When you copy code snippets, you have to make sure everything's changed. Change this to N. Okay, I hope that's right. Now that we got AL, AR and BL, BR, so we figure out what the terminating case is for this while loop. The terminating case is if AL is less than or equal to BR and BL less than or equal to AL. Means that median is within AL, BL, AR, BR. So figure out the left and right elements of the median. So the left element's gonna be L equals max of AL, BL, depending on, I guess it's gonna be one of AL and BL. AL and BL are to the left of the median. They might coincide with the median, but they'll never be to the right of the median. Similarly with R. Min AR, BR. Now we have two cases. If total length M plus N is odd, median is only one of the elements, and that is L in this case. Else, which means the total length is even, median's gonna be L plus R by 2 and return the median. So this is when AL's less than BR and BL's less than or equal to AR. If that is not the case, the while loop continues. So this means either AL is greater than BR or BL is greater than AR. If AL is greater than BR, it means AL is too high. Move the boundary left, which also means eliminate the right partition. You see the boundary that we showed previously, it separates the array into the left and the right partitions. So if AL is greater than BR, which means AL is too high, That means I is not gonna be in the right partition. The partition needs to be lowered. So you do that by setting high to I minus 1. So high is like the maximum value that I can be, and low is the minimum value that I can be. And if this is not the case, there's only one other possibility else, and that is BL is greater than AR, which means AR is too low, which means you have to move the boundary right. When I say boundary here, I'm talking about A's boundary, not B's boundary. When you move A's boundary left, it means you have to move B's boundary right. So move the boundary right here, or maybe I can just change it. A's boundary right, A's boundary left, or at the left. I'm just trying to be as articulate as possible. There's no way you are going to be able to write all of this in an interview or in some coding competition or whatever. You're not gonna have enough time. You skip straight to the coding solution then. So you eliminate the left partition. You do that by setting low equals I plus 1, which is similar to this, just the other way. So once this or this has been done, you get back to the while loop and run this once again. This is a typical setup for any two-pointer problem in an array. As we move forward, we will get even more detailed. In the future, we will see more cases where the two-pointer method is employed, and we'll try to get a generalization for that. Right now I'm just trying to get to the solution as soon as possible. And yeah, this is it. This is where you return the median. And additionally, when you use a language like Rust demands that you return something in a while loop, even if it is guaranteed that you will get to this situation, because Rust is very conservative. It just wants you to code better. So I'll just put this here. You don't need it for the most part. I don't think C++ or Python demand that. Yeah, I'm just seeing if everything's being done. Also, don't spend too much time on the pseudocode. It's not worth it. Okay, let's try to get this finished as soon as possible. So first we need to make sure that A is the smaller array. One way to do that is with this. If len nums1, we are not setting m and n as of yet because we want to make sure A and B are fixed first. Is greater than, len of nums2, return find sorted arrays of nums2, nums1. I hope this is the syntax. So what this does is it swaps nums1 and nums2 if nums1's length is greater than nums2. So yeah, it's not exactly recursion, it just calls itself once again. So there's not gonna be too much overhead even though the stack size increases. So now AB equals nums1 nums2 a what now? Yeah, m n equals len a length of b. We're coding it in Python in case I haven't specified it, but as you can see from the extension here. Okay, now we set k. See, the order is important. We need to set k now. So we set k to be m plus n plus 1 /2. So what this does is, if you put a double slash, it makes sure the resulting output is an integer as opposed to something with digits after the decimal point, real numbers or floating point numbers, sorry. So the reason we are doing this is, remember in our case m was 5 and n was 7 in the example, I mean. So 7 plus 5 plus 1 is 13. 13 /2 will give you 6, which means the median's position is number 6 when the array is either of length 12 or length 13. Or rather, it means there are 6 elements in the array that are less than or equal to the median. Let's say that's what k is. Number elements in the merged array less than or equal to k, less than or equal to the median. Sorry. Yeah, that's what it means. I hope that's what it means. Okay, anyways, we'll get back to it later. Correct me if I'm wrong. We are very flexible here. Okay, next. Gotta speed up. Yeah, this thing's transformed to this because this is more generalizable. And then the corner case, yeah. If a equals this, or rather if length of a equals 0, I guess this is more portable, so, or rather if m equals 0, that's even more portable. Equals, what am I doing? Then I guess you'll have to do the odd even thing. If n %2 equals 1, which means the length of b is an odd number, then median equals would it be or rather first we'll define this to be, we'll define the index to be j, so median is gonna be b of j. J is going to be I guess it can be generalized here. Just put j here. If the length is odd, median is b of j, else median equals b of j minus 1 plus b of j by 2. So the median can be a float, or actually it is a float. It can be an integer or not, depending on the specific values of bj minus 1 and bj. So this thing was derived the same way. We have this in the odd and even case. So we got L. In this case, L would be bj minus 1, R would be bj. Maybe there's a better way to describe this, because I want this to be L. I guess it's R in this case, but it's fine. We'll get better. Time matters more. Time and the final value accuracy. So now we begin the while loop. Remember, you can spend up to 30 minutes in a question like this. On a question like this, I mean. Oh yes, now you define low and high. Low comma high equals m comma n. Here the corner case is done. Oops. Always remember, or don't forget to return the answer. This is a mistake. 0 comma m. So these are bounds of I. If, or rather, now we begin the process where we adjust the values of low and high to set the partition, finalize the partitions, I mean, while low is less than or equal to high. So this means it is valid. Oh man, I keep forgetting what to say. Yes, I equals low plus low plus high by 2. Once again, this ensures that I is an integer, and also I would be to the right. It is supposed to be either greater than or equal to the median, not less than. And which means, I'm sorry, a of I is supposed to be greater than or equal to the median. A of I minus 1 is supposed to be less than or equal to the median. But then again, a of I or a of I minus 1 may or may not be defined depending on where the location of I is. J equals k minus I. Simple. So what this means is there are I elements in A and j elements in B that are to the left of the kth element, and our kth element would be the median. I mean, it's not the kth element, but there are k elements before the median. Medians can, there's a possibility the median is not even an element in the array. Now that I and j are defined, remember you can't do this in line. You can't say I comma j equals this, because j depends on I, and I wasn't defined before. Okay, now that I and j are defined, we define AL, AR, BL, BR. Let's do this individually so that we don't make any mistakes while copying. So AL is by default I minus 1. If, what's the default case? I is greater than 0. If I is equal to 0, I minus 1 would be minus 1. And in Python, I guess if you put minus 1, you're gonna go to the end of the array, the right end. You don't want that. It is supposed to be minus infinity. Or in Python, this is how you represent it. Again, I'm not assuming you don't know all of this already. We are just revising. And if you didn't know this, you're welcome. There's always a first time. J is greater than 0, else math negative math dot infinity. I'm not defining import math at the beginning because LeetCode tends to have imported all of these already. There are exceptions, but most of these are already imported. Oh, oops, this is j minus 1. B of j if j is less than n, not m. Else, be careful guys, this is one of those places where you spend a lot of time debugging. I did it when I was solving this problem for the first few times. Yes, first few times. You have to practice this as much as you can so that you develop an intuition. Yes. Now you have to see if the terminal condition has been reached. Terminal condition is when AL less than or equal to BR and BL is less than or equal to AR. See, we are making sure these 4 elements are properly defined, even if I minus 1, j minus 1 j may be out of bounds. Okay, that is important. AL is less than or equal to BR, BL is less than or equal to AR. That's the terminal case. If AL is less than or equal to BR, now you define L and R. L and R are the possible neighboring elements of the median. They are like the bounds. LR equals max. I wish there was better language to describe them. Maybe there is. BL min AR BR. I'm going to be making this video once again later on. It's gonna be better, I promise. So L and R have been defined here. So now you got the odd case, or rather the even case. Let's start with the even case. If m plus n, it's the total length of the array. If it's even, it means median equals L plus R by 2. It's right between L and R. L and R are actually element values from the combined array. Else, so this is the odd case. Or should I just put it here? I need to decide on a standard. Okay, we'll just put it here. Median equals L. I don't like that it is R here while it's L here. I'm gonna change that next time. Return median. The reason I'm not trying to change it here itself is we got limited time, and then when you solve more problems, there's like, I don't know, 4,000 array problems on LeetCode. The more problems you solve, the more generalization you can do. It's been a while since I solved these problems. I'm just recapping, but I'm going to be consistent from now on, and so should you. It's gonna be helpful. Okay, so we are returning it here. What if this is not the case? What if else if else greater than PR, which means move is path wall to the left. You do that by eliminating the right partition. So you do that setting I equals I minus 1, because the current I is wrong, it's too high. So the upper boundary of I would be 1 less than I. I is too high. Else, like we discussed before, we have only one possibility here. I is too low. I just skip this. You know how these can be translated to the other case. Low equals I plus 1. And that's it. After this, get back to the while loop and run this once again. That's pretty much what it is. And yeah, that's it. You don't have to put a return statement here or for the function definition, because it either terminates here or it terminates here in the corner case. So you're good. Alright guys, there's just one thing to change. I forgot to do this, but other than that, I think our solution is going to work. Copy this, put it here, and let's see. Yep, there you go. Yeah, I just submitted it without putting the self and it gave an error. I just fixed that. Let us submit this. And there you go. It's been accepted. But let's submit it again. Keep an eye here. You see that it just bounces around, so don't really pay any attention to this. So coming back to the pseudocode, our time complexity is going to be of log m. So m is the length of A, and A is the smaller array. So this complexity is really good. And the space complexity is basically O of 1, because we are just reusing the arrays that were provided as arguments to the function. I'm just making sure it's 1 and not an L. And yeah, that's it. The Python part has been done. I'd like to focus on translating the same pseudocode to C++ and Rust. Remember, we will be writing idiomatic code. Idiomatic code for C++, idiomatic code for Rust. And that means we just follow some principles that are specific to that language. For example, in Rust, you're supposed to be specific with the type. As in, you can't use an integer and just say float of this number equals this integer. You have to typecast it explicitly. I don't think you have to do that in C++, but yeah, that's how it goes. Okay, let's get to C++ now. Okay, let's move on to implementing the C++ version of the same code. Well, I will be referring to the pseudocode, but remember, when the time is limited, just combine them. Your C++ will be your pseudocode. So once again, auto equals auto end. So what does this mean? It means A is gonna be a vector int, and it's also a reference. It's a reference to nums1. Oh wait, first we need to check the lengths. Like always, I keep forgetting. Oh man. So if nums1, so in C++ you don't use length of nums1, you say nums1 of size is greater than nums2 dot size. I know some of you already know this. This is just a practice session. Okay. Shh. Return apparently in C++ you don't need to put self. This is one of the reasons why I'm implementing it in Python, C++ and Rust. One reason is to compare them. See, not just in performance, I would say, just to see how the principles differ, the coding principles. So auto and A equals nums1. Once again, here it's fixed. Auto and B equals nums2. There are many ways to write this. I guess you can write it, you can just put a space here as well, but I'll leave it like this for now. So now A and B are fixed. Int m equals, I just wrote auto because vector int is a little too long. I guess you can just write int m. You can put vector int here, it's just too long, but int is short enough, so I'll just leave it as is. Int m equals nums1 dot size. I'll just put a comma here, then equals nums2 dot size. We are trying to explore as many topics as possible. For example, how inline coding is done in C++ as opposed to Python. What is this? Okay, never mind. In Python, see this? C++, you do it like this. You do the first assignment and followed by the second one. M and N are defined. What's next? You get the position of the median, which is once again int k equals m plus n plus 1 by 2. Yes, you just make sure it's an integer, and then comes the corner case. Oops, this is a common made in C++ and JavaScript, I guess. JavaScript, TypeScript, whatever their collective term is called, corner case. If A is empty, how do you say that here? If M, or rather we can just say how shall we type it as? Let's do if not M. So basically if M is not 0, this will be true. So this is one way you can write the conditions in C++. Can we do it in Python? I don't recall. You can't do it in Rust though. I'm pretty sure you can't do it in Rust. I could be wrong. Okay. What do you do here? I guess these things need to be converted in pseudocode. We'll just refer to Python for now. This pseudocode is not perfect, but this is, because this thing runs. Maybe we'll refer to Python only. I know this is not the standard way to do things, but it's okay. Let's just cut some slack. You see this? I'm not a fan of this expression, but in C++ you can write j equals n by 2, and it's gonna do the same thing that this does. And we'll just yeah, median's gonna be a double. I remember how we did the if else here. We'll do it inline here, similar to this. So n %2, this is how we do it here, n %2 question mark, and then what was it here? Yeah, b of j, else you put a colon followed by bj minus 1 bj by 2. See, since it's a double, it gets casted appropriately. If it's an int, this becomes an int. I don't think that's the case in Rust. We'll see. Oh yes, or return median. So this is it. This is the corner case, and then you got the bounds. So I'm looking at this because this is the more accurate version of the pseudocode. We were supposed to cover these things in the pseudocode itself, but for now we'll just leave it as is. So now you got int, once again low and high are integers. Low equals 0, high equals m. Low equals 0, high equals m. I guess this is where we just start the loop. So while low is less than or equal to high, while low is less than or equal to high, first you define int I equals low plus high by 2. Hope that's the case. Yes, it is. J equals k minus I. Okay, I and j have been defined. Now we get to the integers. Should we do auto or should we do let me think. Everything's, I mean, as long as it's int, you can just put it as int. Al equals, remember the condition. See the conditions here? I is greater than 0. In C++, the condition comes first. I is greater than 0. Question mark followed by the default case. And then negative infinity. The way infinities are represented in C++ is limits of int and min. So this is how it's represented. So this is negative infinity. You put max here, it's gonna be positive infinity. So what I'm gonna do is I'm gonna define a macro. Copy this, come to the top, define NL. NL stands for numeric limits, and then put it here. Just replace this because it's way too long. Int AR equals oh yeah, this error is because we haven't put the libraries here, but in lead code I have solved this before, so I know this library is defined. I mean the library that gives numeric limits, the math or whatever it's called. I less than m, yes. A of I minus 1. Wait, what am I doing? Oh, oops. This is I minus 1. Max. Yep, that's it. You replicate the same with B. BL equals j is greater than 0, question mark, B of j minus 1. Oops. Trying to keep it standard so it's easier to read as well. BR equals j is less than m, question, B j NL max. Okay, so this part's done. What needs to be done next? Assume this is our pseudocode once again. It's not like you implement Python first and then C++ in a coding competition. That just makes no sense. You don't even write the pseudocode. That's okay. Once you get enough practice, you don't really need to put the pseudocode. The programming language itself becomes pseudocode. So yeah, here's where your terminating condition is met once again. AL is less than or equal to BR and oops, I keep forgetting the syntax. Forgive me guys. It's gonna look better with, okay fine, we'll just leave it like this. BL is less than or equal to AR. So this is the terminating case. Oh yeah, you define left and right. And L equals max of AL AR, R equals min BL BR. Yeah, you just calculate the median here. So first you write the condition. Remember, in C++ the condition comes first in inline conditional statements. How do you do this? M plus n, combined length percentage 2. So this means it's odd. If it's odd, then L. Else it's L plus R by 2. Let's just put 2.0. I think if you put 2.0, then all of this gets cast to a double. Otherwise, this thing gets evaluated as an integer first, or rather this gets evaluated as an integer first, and then it gets casted to a double. So you're gonna lose some precision. For example, the average of 4 and 5 is 4.5. It gets evaluated as an integer, so it becomes 4, and then the 4 is cast to a double. So it becomes 4. You don't want 4, you want 4.5. Yes, return the median here, and then you have these other conditions. Else, if you don't have an elif in C++, a else greater than BR, it means I is too high once again. So I equals I minus 1. This is the upper bound of I. Else, once again, there's only one case. I is too low. Low equals I plus 1. Yeah. So I guess this is it. Let us see. I hope this compiles. Give me a moment. Alright, I just made a few corrections to the code. So the first one was this thing right here. It's supposed to be a 2.0, like I said. Otherwise it's gonna evaluate to an integer and then cast it back to a double. We don't want that. We don't want the integer part. It has to stay as a double. And then I guess this thing, be careful guys, things like this, it was M, I changed it to M. They can be a big headache and it can take out a huge chunk of your time. Sometimes it took me up to 20 minutes to debug something very simple. And then what else? Yeah, after A and B are assigned, set temp to be the sizes of A and B. So that way, I mean, you don't have to. So I initially put nums1 and nums2. It's not gonna make a difference. It just makes it easier to read. Because here we know A is guaranteed to be not bigger than B. So M is gonna be less than or equal to M. So yeah, let's copy this, and yeah, I just submitted it here, but let's submit it again. Test cases. Okay, now let's submit it. And yeah, it beats 100% of the solutions because yeah, like we've seen here, the time complexity is O of log m. It only depends on the length of A, not the length of B. So imagine the length of A is like 2 or 3 and the length of B is like 1000. It still depends on the length of A alone, not the length of B. There are other solutions where it depends on both the length of A and B. So this would be something like log of m plus n. I guess that's a more generalized solution that can be applied to some other problems. This is also a generalized solution because it depends on the usual two pointers method, which is used in half the optimization problems, especially in arrays. So yeah, this is the best solution, and this is something that's very useful. Okay, yeah. Now let's move on to Rust, and that's gonna be the end of it. Okay, let's move on to Rust now. So this is our Rust template. So in Rust, in the place of C++ int, we use i32, and in the place of double, we use f64. So let's use the C++ code to translate it. I guess for this video we'll just translate. We just what do we say? Adapt the pseudo code to Python, adapt the Python code to C++, adapt the C++ code to Rust, because we are making incremental changes in each. So first we deal with the situation where I guess you could say the length of nums1. So if nums.len, nums1.len, this is how you define the length in Rust, as opposed to nums1.size in C++ and len of nums1 in Python. I'll just put them here for comparison. See this, and now you got this. Actually in Rust you don't even have to put the brackets. Is greater than nums2.len. Why is this showing that? I am not sure. We'll see. Return. In Rust as well you have to define self. Rust is a very cautious language. And then you swap these, nums2, nums1. I guess in Rust by default, if you assign nums1 to A, it is taken by reference, I think. So yeah, return this. Maybe I can get away with just putting this. So this is another way to return in Rust. So remove the return, remove the semicolon, and you get your thing. So by default the auto keyword is applied at Rust. So we'll define A and B inline. mute A, mute B equals nums1, nums2. So the brackets are needed here, or rather the parentheses. You don't need them here in conditions, but you'll need it here. Okay, so after this, see this IMPL. So this is more like a namespace in C++, not a class. I think. I don't recall. Oh man, we got a lot of languages. Okay, let's get back to work. Let mute M. Actually, I don't think we need to set these to mute. Things are immutable by default in Rust. Everything. Integers, arrays, everything. And whoops. A.lem. So here M is guaranteed to be smaller than N. Let's get back here. Okay, we define K. Let K equal. So all of these are constants. You are not going to change them later on anyways. So M plus N plus 1 by 2. Since all of these are integers, K is going to be an integer. If you want a double, you have to typecast it first. We don't need it here, but we will be in the next steps. I'll show you how to do that. If M equals 0. Oh, whoops. Don't need this. If M equals 0, once again, let J equals N by 2. Let J equal N by 2. I want to sound correct. Come on. What am I doing? How do you do it in Rust? Oh yeah, let median followed by, it's better to explicitly mention it here. Okay, in Rust it is kind of similar to Python. Okay, in C++ you got this. What does this mean? If n%2 equals 1, and then for oh man, sorry. Oh wow. What's the condition again? So this means it is odd. If it's odd, median equals J. Sorry, not J. B of J. Else it would be B of J minus 1 plus B of J by 2. I don't think we need a oh yeah, you have typecast here as well. f64 as f64. Here you can just put 2.0, I think, 0.0, or you can just do 2f64. Yeah, we'll just do 2f64. I think that's fine. So you have to typecast the numerator, you have to typecast the denominator, and then you have to divide them. See, Rust is very particular. Return median. Okay, what do we do next? Int low equals let low equal, actually low is supposed to be mutable because we change the values later, so we define them as mute. See, nothing else is mute previously. Let mute low equals 0, mute high equals m. Yep, that's it. Also since low and high are supposed to be indices, I and j are also kind of indices. Highest values can go from 0 to m, and then the boundary just keeps shrinking. So we will set this as u size, and index is supposed to be of size u size, as u size. This is how you define it in Rust. Next, let mute median. So in Rust you have to have a value all the time. Let's just define median here. Okay, mute median equals, or yeah, actually since I said it anyways, the reason we are going to do this is because, I mean, we are returning a value here, but if we say return median here, then median needs to be defined. I guess you don't have to make it mute. I'll remove it for now, just forget what I said. Save it. Now we got the while loop again. Low is less than or equal to high. I don't know why it shows as red. Interesting. We'll see. While low is less than or equal to high, you first define I. Once again, I is not mutable. I is only defined within the scope of this while loop, and for each loop the values of I and j are gonna be constant, so you can just leave it immutable. There's a reason why Rust does that. Let I equals, it's gonna be similar to C++, low plus high by 2. Yeah, so low from here is gonna be a u size, so low plus high by 2 is also gonna be a u size, so I is going to be a u size. So when I is a u size, this will be defined. If I is an integer, this gives an error in Rust. In C++ now you can have it as a signed integer, but in Rust you have to convert it to an unsigned integer. So let I equal low plus I by 2. Actually we are defining both I and j. Let's keep it as inline as possible to group these together. We need an additional pair of parentheses here, semicolon, and then k minus I. Is k defined? Yes, it is. Okay, yes. These are also not mutable. If so, this is the default case. What's the default case? I is greater than 0. Oh man, what's with these? No. That should be this one. Okay, something's wrong. What is it? Did I miss a brace here? No, that's not the case. Okay, must be this. Okay, we'll figure it out. Don't worry. I was just looking at this. There seems to be a brace mismatch. So here it's going to be a of I minus 1. Here it's going to be, it's easy in Rust, I32, which is basically signed integers, min, and that's it. That's how you get the negative infinity. Similarly, this is AL, not AI. Oh man. I is less than M. A of I, else I32 max. Why is this a different color? I don't know why this is happening. Oh, okay. For some reason it's parsing these as pairs, like angular braces. Angled braces? I don't know. Square braces? No, not square braces. That's a different thing. Okay, let's just keep going. If j is greater than 0, b of j minus 1, else I32 min. Br equals if j is less than m. B of j, else I32 max. Hopefully okay, we'll see, don't worry. What if I just put return here? Interesting, that's not changing anything. Okay, anyways, let's continue. We are going to finish this. less than or equal to BR, and I am pretty sure you don't need parentheses here. EL is less than or equal to AR. What about yes? Now you define the left and right elements. Once again, let L or rather LR equal max AL BL min AR BR. Let median equal. See that in Python we did not do the inline conditional, but in C++ we did it. We'll do the same here. If take the art case first, it's easier. M plus N percentage 2 equals 1. That is the odd case. The median would be L. Else it would be L plus R. Remember, you have to typecast it. F64 by 2 F64. Similar to this, similar to the corner case. Okay, now that this is done, just return the median. Else, I'm gonna skip the comments because it's easier that way. If AL is greater than BR, you know what it means. Means I is too high. I is too high. Reduce the upper boundary. Pull the upper boundary down. Equals I plus 1. Simple. Else low equals I'm sorry, it's I minus 1 here, it's I plus 1 here. Now the thing is, there are two conditions. The reason we are putting parentheses here, remember, in C++ we can actually eliminate the parentheses and you can just show this here, and that's gonna be valid. Whereas in Rust, also in C++, the parentheses are, the conditions parentheses are mandatory, whereas these aren't. If it's a single statement, you can just skip these. In Rust it's the opposite. You don't need parentheses, but you'll need the flower braces or curly braces. Okay, now that this is done, you can just simply so it's the while loop. If it exits the while loop, you still need to put a return, otherwise it will throw an error. It was the same with C++ too, I think. You can simply put this, and this should be good enough. And yeah, I think this should work. Okay, let me just give it. Okay, I was facing some weird delimiter issue, which somehow solved on its own. Got solved on its own, I mean. Had to make a few changes. For example, when did this thing jump? Oh yeah, So I and j, they can't be defined inline because j depends on I and I wasn't defined for. I mean, you are supposed to define them one next to the other. J needs to be defined after I has been completely defined. Just make this smaller. And then yeah, it's just, I don't know why this thing shows as red. Something weird's happening. And then yeah, the final -1, this is the default return value. You need to typecast it to F64 because -1 is an i32 by default and the return type is F64. And yeah, this thing's compiled. I'll just run it once again. Submit. And yeah, here's our solution. So disregard this thing just bounces around. As long as your solution is optimal, it should be fine. So yeah, there's that. Yeah, so yeah, that's pretty much how you deal with this problem. It is very similar to many other two-pointer methods. I guess the simplest two-pointer method is gonna be given an array, a sorted array, and a specific number, find the index of that number. I think that's one place where you can try to understand how the two-pointer method helps, because it reduces the time complexity from the default O of m or O of n to O of log m by using partitions. So that's it. That's how you solve one of the LeetCode hard array problems. I will see you soon.